All right, we've introduced you to the parent functions. Now we're going to go ahead and apply the transformations. This makes our graphing a lot faster when we know our transformations. So we're going to start with movements left and right. So here is the horizontal shifts that happen. I do need you to write down this piece right here, y equals f of x plus 3. That needs to be written down. And then this right in here, this is very important. When you add c to inside the function, what it's going to do, it's going to shift the entire parent function to the left, and how much you move it is whatever this c value is. So to create your new set of ordered pairs, you're going to subtract c from all the x values. Why the x values? That's your horizontal axis. It's your x-axis. So you're shifting everything to the left. So you have to subtract c. So I tell my students, think opposite. The other way is if you have a subtracting c. Then we have to say that it's going to shift to the right. And how we get our new set of ordered pairs is we're going to add c to all the x values from the parent. So let's go ahead and show you on the next slide. Now that's probably a little bit fast for you, so I want to make sure you pause and then ready to move on. So these next two examples I do not want you to write down. We're going to take care of doing some together. So here is our parent function, y equals x squared. This is our parabola. And then our new equation with the transformation has this minus 3. So if you think about that, that is a minus 3. So that's going to shift it to the right 3 units. So in the red is our parent, our parabola. And now imagine shifting right 3 units. So if here is our origin, 0, 0, it's going to shift to the right 3 units, 3, 0. So to create our set of ordered pairs, here is our parent, ordered pairs, and for us to move it 3 units to the right, we're going to add 3 to all of our x values. So notice the difference. Here's 0, here's 3. We're adding 3. Negative 1, we're adding 3. We'll continue doing that, and then we can graph our new set of ordered pairs. Now the next example I said for you not to write down. So here is our parent that we graphed earlier in the last example. And those are the set of ordered pairs. Now here is the new graph equation. Y equals x plus 3l squared. Noticing it's an adding 3. So when you add 3 inside the function, you're going to be shifting it to the left. So you're going to be subtracting 3. So notice our origin of our parent is at 0, 0. And now we're shifting it to the left 3 units. So now that critical point is at negative 3, 0. So to find our new ordered pairs, we're going to take these x values and subtract 3. So if we had 0, we subtract 3, we're at negative 3. At negative 1, we subtract 3, we're at negative 4. Again, you are not writing this example down. All right, this is the example I want you to write down. I've saved you a little bit of time. I graphed our parent already in the purple. And we're graphing an absolute value parent. So the absolute value parent equation is y equals the absolute value of x. And here are all our ordered pairs, and then we've graphed them out in the purple. Now we're going to go ahead and do a transformation. So we have our x, and now I'm going to go ahead and say y equals the absolute value of x, and let's say plus 4. So what's inside the absolute value? This is a plus c. So if you remember back in your notes, when you go plus c, you have to think opposite. You're moving to the left c units. So we're going to have to subtract c units, or subtract 4 from all the x values. So all of these x values from up above have to be subtracted. So let's start off with the first one. When we subtract 0 from 4, we get negative 4. Negative 1 minus 4, we get negative 5. 1 minus 4. Negative 3. Negative 2 minus 4. Negative 6. 2 minus 4 is negative 2. Now, we did not change anything on the y value, so all of these just go ahead and come down, 0, 1, 1, 2, 2. Now let's go ahead and graph it. The first ordered pair is left 4, up 0. The next ordered pair is negative 5, up 1. The next ordered pair is negative 3, 1. The next ordered pair is negative 6, which is a little bit off my graph, but that's fine, up 2. Next ordered pair is negative 2, up 2. Now we go ahead and graph those set of ordered pairs and connect our lines. Notice that it's shifting left 4 units. All right, same parent function. We've already graphed it for you to save some time. Now let's go ahead and say y equals the absolute value of x minus 2. So this is a minus, so we're going to have to think opposite. It's a minus 2, so we have to think we're moving right 2 units. So what we have to do is we have to add 2 to all of our x values to move it to the right, x. Here is our x. We're adding 2 to all of those values. So the first one, 0 plus 2 is 2. Negative 1 plus 2 is 1. 1 plus 2 is 3. Negative 2 plus 2 is 0. 2 plus 2 is 4. So all of these values have not changed. So we just go ahead and repeat them. 0, 1, 1, 2, and 2. Now we're set to graph our new function. So we're going to go right 2, up 0, right 1, up 1, right 3, up 1, left 0, up 2, over 4, up 2. Created our new graph with our transformation, noticing that it's shifting to the right 2 units. And that's how you can do parent functions shifting left and right.